If we get the derivative of the trigonometric functions using the chain rule, we must always observe that this function here. So it means to say when this function is differentiable, or should I say its derivative is not 1, then you have to follow this. Take note that when the derivative is simply 1, then the answer is simply cosine u in sine function. Negative sine u. Okay, but observe that when that is letter C, we always have negative here. Just cotangent, negative, cosecant, and there's negative sign here. Okay, so let's have the first example. So in this first example, this is 10x, and we know that this 10x is differentiable, and its derivative is equal to 10. So we get the derivative now of sine u. Okay, we let 10x be equal to u, and that is equal to cosine u, but u is still differentiable, so times u prime, and this will now be equal to cosine of 10x. Let u be equal to 10x, and that you multiply that to u prime, which is 10. So our answer is 10 cosine 10x. On the second example, we observe this x squared here, so u that is equal to x squared, and that is still differentiable, and the derivative of u that is x squared is u prime that is equal to 2x. So we may now rewrite this one into the derivative of cotangent u with respect to x, and that is equal to, that is negative cosecant squared u times the derivative of u. So let u be equal to x squared, so we have negative cosecant x squared times 2x. So our final answer is negative 2x cosecant squared x squared. So in this case, we let 2x plus 1 be equal to u. So u is equal to 2x plus 1. And the derivative of 2x plus 1 is equal to 2. So this will now be getting the derivative of secant u, and that is equal to secant u tangent u times u prime. Now let u be equal to 2x plus 1, so we have secant of 2x plus 1 times tangent of 2x plus 1 times 2. So we have 2 secant of 2x plus 1 multiplied to tangent of 2x plus 1. And the next example here is tangent 3 raised to x plus 1. So let u be equal to 3 raised to x plus 1. So the derivative of that is equal to 3 raised to x plus 1 times ln of 3. Therefore, we may now have we may rewrite that into the derivative of tangent u, and the derivative of tangent u is equal to secant squared u times u prime. So we have secant squared of 3 raised to x plus 1 multiplied to 3 raised to x plus 1 ln of 3. So our answer can now be written into 3 raised to x plus 1 ln of 3. Okay, we may enclose this one, secant squared of 3 raised to x plus 1, or this enclose also this. So that is your final answer. Next, we have the derivative of cosine of ln of x. So here, let u be equal to ln of x, so that we may now have the derivative of cosine u, and that is equal to negative sine u times u prime, because u prime here is 1 over x. So derivative of ln of x is 1 over x. Now, palitan natin ng x na ito, ng u na yan into ln of x. So we have negative sine of ln of x times the derivative of ln of x, and that is 1 over x. So our answer is negative sine ln of x over x. The other example, we have cosine. On this example, we may observe that this u here, which is 4 raised to 2x plus 1, when you get the derivative of this, it will become 4 raised to 2x plus 1 ln of 4, but you can also observe that 2x plus 1 can also be differentiated and its derivative is 2. So you have to multiply that by 2. So that the derivative of u here will become 2 times 4 raised to 2x plus 1 ln of 4, or can be written into 2 ln of 4 times 4 raised to 2x plus 1. You just need to enclose this so that if we rewrite this one, this will now be the derivative of cosine u, where u is equal to 4 raised to 2x plus 1. So we have derivative of cosine is sine, negative sine u times u prime. Let u be equal to 4 raised to 2x plus 1. So we have negative sine of 4 raised to 2x plus 1. Multiply that to the derivative of 4 raised to 2x plus 1, which is already solved here. So we have 2 ln of 4 times 4 raised to 2x plus 1, and our final answer will now be, this can be negative 2 ln of 4 constant, multiply that to sine of, okay, so we just need to be very careful in the parentheses here. So that will now be sine of 4 raised to 2x plus 1, and multiply now that to 4 raised to 2x plus 1. So we just need to enclose that. Or we can also observe here that 2 times 4 raised to 2x plus 1 can actually be written into 2 times 2, factor of 4, make it exponentially 2 raised to 2, so 2 raised to 2 times 2x plus 1, and that will become 2 times 2 raised to, distribute 2 times 2x plus 1 here, so we have 2 raised to 4x plus 2, and since this is 2 raised to 1, you can add the exponents. Okay, we need to add the exponents, so we have 2 raised to 4x plus 3. Now this means that our answer here, instead na may 2 dito, pwede natin siyang i-replace o tanggalin na siya and magbabago ito. So your answer can also be written, okay, can also be written into negative ln of 4 multiplied to sine, okay, that is multiplied to sine of 2x, just need to be careful on the bracket, so sine 4 raised to 2x plus 1 times, okay, times 2 raised to 4x plus 3. So that can be another way of expressing your answer. Next is, how do we differentiate the inverse trigonometric functions? Okay, so we have this formula, but the only thing we need to observe here is this function here. So kapag ito ay differentiable such that its derivative is not equal to 1, ang mangyayari, kukunin natin ang derivative nito at i-multiply natin sa corresponding derivative of sine o inverse sine. That is 1 over square root of 1 minus u squared for sine. Tapos magiging negative yan kapag cosine, inverse cotangent, negative ulit, inverse cosecant, negative. Just always observe the partners, okay, partners ng dalawa. Okay, when it comes to the how do you describe its derivatives, okay, but observe always that that's c, then you have subtraction, c, negative, negative, and c, that's negative. Okay, so let's have the example. Let's say you're going to get the derivative of inverse cosine of 4x here. So ang mangyayari dito, let u be equal to 4x. So the derivative of arc cosine is equal to, so that can now be written into the derivative of inverse cosine of u, which is equal to negative kasi cosine yan. So 1 over square root of 1 minus u squared, that is in the formula, times the derivative of u. So mangyayari, papalitan natin ng u ng 4x na ngayon. So we have negative 1 over square root of 1 minus 4x. Then you have to square that. And the derivative here of u, which can be represented by u prime, is equal to 4. So you have to multiply that derivative to that. So our final answer is now equal to negative 4. So 4 times 1 is negative 4. So we have negative 4 square root of 1, and the square of 4x is 16x squared. So yeah, minus 16x squared. Next, we have here the second, the derivative of in arc cosecant of cosine x. So here we let u be equal to cosine x, and the derivative of u is equal to negative sine x. So we can write this one into the derivative of arc cosecant u, which is now equal to, so remember the rule, that is letter C, so negative 1 over u square root of u squared minus 1, okay, times u prime. Now let u be equal to cosine x, so we have negative 1 over cosine x square root of the square of cosine x minus 1. Yes, because the square of u, which is cosine x, will become cosine squared x, so you can directly write that way, times negative sine x. So here we can now have negative, okay, so negative of negative sine x over cosine x times square root of cosine squared x minus 1, and that is negative times negative will give us positive. And also take note that sine x over cosine x is tangent x, therefore our answer can now be written into tangent x over square root of cosine squared x minus 1. Take note here that we don't need to replace cosine squared x minus 1 into negative sine squared minus, or negative sine squared x, if you would like to use the Pythagorean identity, because there's no need to do that. Next, we let square root of x here be equal to u, therefore we have the second derivative of second arc secant u, which is now equal to positive 1 minus 1 over u times square root of u squared minus 1 times u prime, and u that is equal to square root of x, the derivative of that is equal to 1 over 2 square root of x. Just need to recall the derivative of radical. So our final answer will now be written into 1, let u be equal to square root of x, so 1 over square root of x, multiply that to the square of square root of x minus 1, okay, times u prime, which is 1 over 2 square root of x. So we can observe here, we can cancel out something here, so this one, we can cancel that now, it becomes simply x. So what will happen, we can rewrite that into 1 over square root of x times square root of x minus 1 times 1 over 2 square root of x. Therefore, we will now have, okay, so here, if we multiply square root of x times square root of x, the answer is simply x. So we have 1 over 2x, okay, square root of x times square root of x is simply x, so x times 2 is 2x, and you have to multiply that to the square root of x minus 1. So this can be our final answer. In this case, we let u be equal to secant x. Therefore, we have the derivative of inverse secant u, okay, can be written that way, which is equal to 1 over u square root of u squared minus 1 in the formula, multiply that to u prime, and now replace u into secant squared, so we have 1 over secant x times square root of the square of secant x, because u is secant x, so replace it, minus 1 times the derivative of u prime of u, which is u prime, which is equal to secant x tangent x, so multiply that to secant x tangent x, and here we can observe we can cancel out tangent secant x here. Therefore, we can now have 1 over the square root of secant squared x now minus 1 times tangent x. Now take note that this can actually be replaced using the Pythagorean identity. Tangent squared x plus 1 is secant squared x. Therefore, tangent squared x is equal to secant squared x minus 1. Ibig sabihin, pwede natin palitan ng secant squared x minus 1 into tangent squared x. So we have 1 over the square root of tangent squared x times tangent x. And tandaan natin na ang square root of tangent squared x can actually be written into square root of the square of tangent x. Therefore, that is simply tangent x. So we have 1 over tangent x times tangent x. And the answer is 1. So in getting the derivative of the inverse cotangent of x cubed minus 1, we have to recognize this. Let that be u, that is x cubed minus x, and the derivative of u is 3x squared minus 1 using the power rule. Therefore, we can rewrite this one into the derivative of inverse cotangent u, which is equal to negative 1 plus u squared times the derivative of u. Therefore, we have replacing u into its corresponding value, which is x cubed minus 1. So we have 1 plus the square of x cubed minus x. Okay. And the derivative of u is 3x squared minus 1. So our answer can now be negative of 3x squared minus 1 over 1 plus the square of x cubed minus x. You may also have your answer as, remember that this is negative. Pag yan dinistribute mo sa numerator, ang mangyari pa, magiging 1 minus 3x squared. So we have 1 minus 3x squared over 1 plus x cubed minus x. Okay, you don't need to expand this. Kasi, well, they're just the same. At wala naman na siyang like terms. Wala naman siyang constant. So, wala rin siyang epekto dito sa 1 na to. So, hindi mo rin naman i-combine ng 1 sa kanya.